Sorry about that. YouTube always cuts the video off at 10 minutes. So we're on number 22. We know that we are going 11 meters per second south. We know the river is going 5 meters per second west. And we want to know what's our velocity relative to the shore. So you're just going to use Pythagorean theorem again, this time looking for the hypotenuse. So v squared is going to be 11 meters per second squared, that's 121, plus 5 meters per second squared, that's 25. So square root of 146 is going to be 12.08 meters per second. But it wants velocity, which means it's a vector, so we have to find this angle. We have the opposite side, we have the adjacent side, so use tan. So tan theta will equal 5 meters per second over 11 meters per second. And so you'll get a theta of 65, not 30. Sorry, I'm doing it opposite in my head. 5 divided by 11. And then inverse tan. 24.4? 24.44. Yeah, I think that's right. 24.44 degrees. So we go back up here, square bracket. What do we measure off of? South. 24.44 degrees. And then which way did we turn? West. Square bracket. And this is our answer to number 22. All right, number 24. I'm just going to take that out here, and if I have enough room, I'll move it down here. Okay, so in number 24, it says 100 kilometers north, and then west for 150, and then south for 50. So you're over here, and you go 100 kilometers north. So this is 100 kilometers north. I might just make it one longer. And then west for 150. So all the way over here, 150 kilometers west. And then you turn and you go 50 kilometers south. Okay, and hopefully you can see a right angle triangle here. Resultant always starts where the first one started, ends where the last one ended. So this is your hypotenuse. One side is right here, and the other is here. So this is obviously, I hope, 150 kilometers west. And this little guy should be 100 kilometers north and 50 kilometers south. It should be 50 kilometers north. And so now we can square them, add them together, and take the square root, again, to get our resultant. So 150 squared, 225 with 2 zeros, plus 50 squared, 25 and 2 zeros. Take the square root, and you should get 158.11. 158.11 kilometers. And then we need an angle, and the angle's going to be right here, always at the origin. So again, we can do opposite over adjacent. So we would do tan theta is equal to 150 over 50. Or tan theta of inverse tan of 3. And when you do that, you get 71.565. So theta is equal to 71.565 degrees. So our answer, square bracket, we were going north, 71.565 degrees, then we turned and went west. Now you could have found this angle down here, and that would be fine too. It would just be the complement, right? So it would be 18.435, and instead of north it would be west, and instead of west it would be north. Okay, so this is the first part of number 24. The second part, that was using vectors, find the total displacement. Second part is the time the airplane takes to fly. The 3 different parts of the trip are 20 minutes, 40 minutes, and 12 minutes. Calculate the velocity for each different part. So it wants, I thought my paper was off. There we go. So it wants V1, which will be delta D1 over delta T1. And delta D1 is 100 kilometers. And the first time is 20 minutes, which is a third of an hour. And so V1 is equal to 300 kilometers per hour. And that'll be north. V2 is just delta D2 over delta T2, which is 150 kilometers. And this one it says 40 minutes, which is 2/3 of an hour. So 450 divided by 2, so it's 225 kilometers per hour, and it's west. And then V3 is delta D3 over delta T3. So 50 kilometers over 12 minutes, it's 1/5 of an hour. So that's going to be 250 kilometers per hour south. So this is part B. Okay, and then the last part of the question says calculate the average velocity for the total trip. Now some people might want to take and average these three, but that's the average of the velocities throughout the different sections of the trip. But average velocity, you know the formula, it's displacement over time. So for the entire trip, displacement over time, the entire trip's displacement is 158.11 kilometers per hour. Kilometers. And the time, 20 minutes, 40 minutes, and whatever that one was, a 1/5 of an hour, 12 minutes. So that should be an hour and a fifth, or 6/5 of an hour. And then if you do the math, you should get maybe, I have no idea. I was trying to do it in my head. So 158.11 divided by 6/5. 131.76 if I did that in the calculator right. So 131.76 kilometers per hour. It's a velocity, it needs a direction. It's going to be the same as your displacement. So north, 71.565 degrees west. Number 24 is done. Number 25. Number 25, you're on a river, you're standing on the south side, and you want to go straight across. Okay, so you want to do this, but you know the river's flowing west. So obviously you're not going to do this, and this is really what you want your resultant to be. I should have drawn it in red. Okay, so if the river's flowing west and you aim here, you're going to end up over here. You don't want to do that, so you're going to aim this way, and you're going to let the river carry you this way. Okay, so it says you can do 1.9, I think, meters per second in still water, so this is what you're doing. And then it gives you this mumbo-jumbo about a stick. And it says the stick moves 24 meters and 30 seconds. The 24 meters is the delta D, the 30 seconds is the delta T, and from this you can find the speed of the river, because VAV is equal to delta D over delta T. So it's just going to be equal to 24 over 30, or 0.8 meters per second. So the river's going 0.8 meters per second west. And so now, first part of the question, determine the direction that you should head. It wants this guy. So again, you're going to do sine theta. So sine theta will equal, because you have the opposite, and you have the hypotenuse. So inverse sine up both sides, and you will get theta to be 24, I think. So what is it? 0.8 divided by 1.9. Inverse sine. 24.90 degrees. 24.90 degrees. Of course, we need a direction. We're measuring it off the north. 24.90 degrees. And that will